Addition and subtraction of sinusoidal quantities.
Welcome to this class of King Solomon and People's Daily. In today's class, we are going to, still under phasors, we are talking about the addition and subtraction of sinusoidal quantities. Addition and subtraction of sinusoidal quantities. Now, there are some key points you are supposed to note under this very subject matter. And these 3 points: 1,
The sum of sinusoidal quantities is obtained by taking the vector sum of their phasors. The difference of sinusoidal quantities is obtained by first reversing the subtracted quantity and adding it as a vector to the other phasors. A sinusoidal quantity is reversed by adding 180 degrees to its angle. Only sinusoidal quantities of the same frequency can be added or subtracted.
Okay, so from the key points that was read, there are basically some things you are supposed to take note. From the key points, you understood that anytime they said that if you want to find a difference between two sinusoidal quantities, but always take note that first of all, sinusoidal quantities can be added or subtracted when they have the same frequency. So now, most of them will be seeing the omega t, which is the same as 2 pi ft. So the omega is what? 2 pi f. Now, if you see any sinusoidal quantities or two sinusoidal quantities, and the frequency that was given is not the same. For example, if you see a sinusoidal quantity with an omega t, and you see another sinusoidal quantity with maybe 3 omega t, you should note that the frequencies are not the same. Pi is always a constant. The 2 here is a constant. The t there is a constant. So what will change to affect the 3 here is obviously the frequency. So anytime you have maybe a sinusoidal quantity of omega t and 3 omega t, note that the frequencies here are not the same. Okay. Again, too, it says that if you want to find the difference, what we are supposed to know is that you have to reverse. There should be a reverse. So now, if you want to find a difference between two things, and the one you have to find a difference, first of all, you have to do the reverse. And how do you do the reversing? Reverse by adding, maybe for instance, you have this, maybe let's say minus 90. And you want to reverse a sinusoidal quantity of such nature. What you do is that you have to add 180 to each phase angle. So if you add 180 to each phase angle, you've reversed it. And that's one thing you're supposed to also note in doing the difference. Let's take this question together and let's look at how we deal with it.
Okay, so let V1 of t equal to 60 sine omega t and V2 of t equal to 80 sine omega t minus 90. Determine A, V1 plus V2, and B, V1 minus V2.
We have two sinusoidal voltage quantities. And the first sinusoidal voltage quantity, V1, is 60 sine of omega t. And the second sinusoidal voltage quantity is 80 sine omega t plus 90. So the omega is the angular frequency. Okay. And the A aspect of the question says you should find V1 plus V2. Okay. Now, this is a sinusoidal quantity, and this also is a sinusoidal quantity. Now, we can add them because, first of all, we have to check whether their frequencies are the same. So you realize that the frequency here, which is 2 pi f, and the frequency here, which is also 2 pi f, they are the same. So there is no difference or there is no variation within the frequency, so we can add them. Okay. Now, if you want to add them, you have to draw their phasor diagrams, and their phasor diagrams will help us add them very well. Now, what happens is that voltage 2, what we can see is that because here the phase angle is 0, but here the phase angle is negative 90, we can say that the voltage 2 is lagging voltage 1 by 90 degrees. So the voltage 2 here is lagging voltage 1 by 90 degrees. So if it's lagging voltage 1 by 90 degrees, then the phasor diagram voltage 1 will be in phase. So the V1, which is equal to 60 sine omega t, will be in phase. But the V2 will be out of phase, which is 80 sine omega t minus 90. It's also phased by an angle of what? 90 degrees. Okay, so now if you have this and you want to find V1 plus V2, then you can draw the resultant vector. And the resultant vector here is V1 plus V2. And this is the resultant vector. It is V1 plus V2. Okay. If the resultant vector is V1 plus V2, then let's see something here. How do you find, first of all, we have to find the magnitude of the resultant vector. Now, what is the magnitude of the resultant vector? The magnitude of the resultant vector is simply the root of their peaks. So the peak for this sinusoidal quantity is 60, and the peak for this sinusoidal quantity is what? Is 80. So therefore, 60 squared plus 80 squared. And when you do this, you will get 100. So now, the magnitude for the resultant vector, which is V1 plus V2, will give us 100. Now, if that is giving us 100, how do we find the angle? So now, we want to find the angle here. The resultant. So the resultant angle. So to find the resultant angle, we can use tan. So therefore, tan of the phase angle should be equal to the opposite. So we can bring this one here. When we bring this one here, that is the V2. So the peak is 80. The opposite, which is 80 on the adjacent, obviously, which is what? The 60. So now, the phase angle will become the tan inverse of 80 on 60, which is equal to 53 degrees. So now, this will give you 53 degrees. So therefore, how will you find, finally, the voltage or the addition of the two of them as a function of time? So the addition of the two of them as a function of time will now become V1 plus V2 will become the peak voltage, which is 100 sine into bracket omega t minus 53 degrees. Why? Because this is lagging with an angle, a phase angle of what? 53 degrees. So the resultant vector was also lagging with a phase angle of what? Of 53 degrees. That's why we had the 53. Now let's quickly go to the second question. And from the second question, the B part, we are asked to find V1 minus V2. From the B part, we are asked to find V1 minus V2. Okay, how do we go about that one? First of all, what we are supposed to do is that from vectors, V1 minus V2 is the same as V1 plus negative V2, negating the V2. So now, what we said was that when we want to subtract, we have to reverse one of them. So now we are reversing the negative V2. So the negative V2 reverse means that we have 80 sine of the root t minus 90. And he said we can only reverse unless we add 180. So plus 180 degrees. And so the minus V2 will now give us negative 80 sine omega t plus 90 degrees. Okay, so now we have V1 and we have V2. So since we have V2 as this and we have V1 as this, then we can add them now. We can now add them now. Okay, so now you have to draw the phasor diagram of the two of them so that we know how we go about it. So now realize that here, this is leading by 90. It's not lagging. The minus V2 is now leading by 90. So now V1 is still in phase 60 degrees. Sorry, 60 peak voltage. But the minus V2 is now leading by an angle of 90. So minus V2, which has a peak of 80, is now leading by an angle of what? Of 90. If it's now leading by an angle of 90, then the resultant vector, which is V1 minus V2, will be here. So the resultant vector, which is now V1 minus V2, will be here. And this will be its phase angle. This will be its phase angle. So now if you change there, you can redraw the structure and it looks this way. This is the V1 minus V2. This minus V2. Sorry, and this will be the V1. So this is the phase angle we are looking for now. Okay. So now, what happens is that we have to find the magnitude. So V1 minus V2. Magnitude of V1 minus V2 is equal to the square root of the same 60 squared plus the 80 squared. And that will still give you 100. Okay. And now we have to find the angle. So the angle theta here will also be tan inverse of minus V2 opposite the peak, which is 80 on 60. Sorry. Tan theta of minus V2 on 60. And that will give you 53 degrees. So finally, the V1 minus V2 will be the peak voltage, which is 100 sine omega t plus 53 degrees. Why plus 53? This is the phase angle because it is leading. It is leading the first voltage by what? The resultant vector is leading the V1 by what? 53 degrees. So it is positive. Okay. We will solve more examples on this question, on this particular principle, and I urge you to also try as much as possible to get a lot of questions and solve.